Can you remove me as a co-host? Because I get the pings and it's slightly distracting if you're anywhere there. Oh, thank you. All right. Quickly confirming. Do you know these basic facts? Firstly, what do you know about congruence of triangles? Please, if you can unmute, please unmute. Oh, also, like always, sorry for the terrible handwriting. Uh, okay, so something you were supposed to do in that grade. Sure. Can you quickly tell the criterion?
SSS, SAS, AAS, RHS. This is the same. Come on.
Okay. So does everyone know what these are? What these stand for?
ASA.
ASA or AAS are the same thing, just because of angle sum of triangle. What do you call it? Triangle, what is the angle sum property is it called? What is the term they teach you in school? Right, angle sum property of triangle. Cool. And so you're familiar with this. Okay. So side, and parallel lines. These angles are equal. Again, something you all know, right? Perfect. Yeah, back to seventh grade. Yes, perfect, exactly. For parallelograms, these are equal. This also you know, right? And this is the midpoint. And because of the previous argument we did, this angle is this angle. And these sum to 180 and your general properties that I'm sure you all know. Cool. Quick proof, please. You can assume this. This also you can prove if you want to. Yeah, but quick proof of angle sum property. Run up, you go.
Triangles, right?
Yes.
So let's construct a parallel line and then they are equal and so on infinity.
Perfect. Okay. All those who are like so confident right now, what is he going to do? This is so silly. Stay calm. It takes time to build up stuff. Yeah. So this is the proof. Perfect. So this much stuff I'll assume from now on. That's good, right? And that's all I'll assume. I'll not assume anything else for today. Okay. So not yet. Okay. Who else is active today? So I see Siddharth Bhattacharya. Siddhartha Bhattacharya, can you tell proof of why circumcenter exists of a triangle? Yes. Why does it? Radical axis, my God. What is this fancy thing that you're talking about? Okay, no. Some people are completely ridiculous. Okay,
Can
fifth,
I
I'll
take
allow you to use one more thing because I've told you about congruence.
can I
So
take
this we'll use some facts about isosceles triangles. That isosceles triangles are the only things in which this distance and this distance is equal. So median, perpendicular bisector, and angle bisector are the same thing. I'm being so nice today. I'm allowing so many. Yes, please go ahead.
so if we
Shivam, run away. Shivam, yeah, go ahead.
So if we draw a perpendicular bisector of one side, we can
Okay.
take that point.
Let's say this is my triangle ABC, and you want me to draw perpendicular bisector of BC.
Yes.
Okay.
That's enough. That's enough. Don't draw it. Don't extend it much.
Okay.
Then at the end of the perpendicular bisector, we can connect it to B and C.
What do you mean end of perpendicular bisector? It's okay.
I guess he's
Don't.
talking about intersection of AC and the bisector maybe.
Is that what you meant?
No, that's not what I meant. But yeah, I don't know.
That's okay. Yeah, go ahead, Siddharth.
We can take any random interior point in the triangle and equate the distances from its vertices. Like if a point exists in the plane which is equidistant from all the vertices, then the circumcenter will exist.
Yes. And how does such a point exist?
Like if we plot coordinate axis on the plane.
No. Then nothing. What even? Where did you rush off to? Why are perpendicular bisectors concurrent? What is going on today? People are coming up with crazy facts.
Well, I guess
So
we can take the perpendicular bisector of two sides and the intersection point, like we can call it some O, and we have to show that O also lies on the perpendicular bisector of the other side.
Yes, perfect. So let's call it O. Now, because O lies on the perpendicular bisector of BC, we have OB equal to C. And because O lies on the perpendicular bisector of AB, OA equal OB. Guys, come on, how will we get to ISL problems when you can't tell me circumcenter existence? Yes, so we see from magic fact and axiom that OA equal OC. So O is the circumcenter. And we also get that it lies on the third perpendicular bisector, and then the perpendicular bisectors concur. Magic. Second, orthocentre, please. Pranav, your excitement, please tell me now.
angle chase. Shall I tell the whole angle chase?
Angle chase, no. What is this fancy thing again?
Angle chase is basic. It's the first chapter.
See, all you can assume is point 1 and this. I'm not allowing you to assume anything else.
Complex coordinates.
Coordinates? See, okay, anybody here, whenever you think of the word coordinates, note to yourself. It's a very important lesson to learn. Again, You don't know anything except this page and this page. Come on. What are you talking about? Saver's theorem or some fancy theorem I've never heard of? I'm sure next somebody is going to say radical axis. Michael point. Oh, no, 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 no. No, sir, no. Come, you don't need to know. Think. What is this? I only know. Why it is orthocenter? How prove that the orthocenter exists? Don't worry, it's a tricky question.
Do you consider some parallel lines from the vertex to altitude? Not sure.
Sure, you can create anything you want. I'm not stopping you from creating anything you want to create. Oh, how? This is like an amazing fact. I think this is the fact we are trying to prove. Go ahead. What is the contradiction? Okay. Euler line. Do explain the Euler line, please, Pranav.
The 9-point center.
Oh, okay. What is the 9-point center?
The center of the 9-point circle.
Oh, what is the 9-point circle?
The circle passes through the midpoints of the sides and the, what do you say, like, the feet of altitudes.
Whoa, why does this exist?
By angle chasing, you can show.
What angle chasing?
I mean, you can show they're concyclic by angle chasing.
See, you're using some fancy facts about angles on being subtended on circles. I know nothing of this. I only know this. Like, what are these angles on circles? No, 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 no. Again, what is this stuff? No radical axis. So much fancy kids nowadays. Very good, Parthasarthi. Can you speak up, please?
Just draw a parallel line. Just extend the sides such that they become parallel to the third side, and then there will be a parallelogram.
Sorry, what do you extend?
Each side, like no, sorry, like from B you pass a parallel line to AC, and
Good.
define all such point like this only.
Very good. Go on. What now? Let's call these points X, Y, and Z. What now?
Now this ZACB, it's a parallelogram, and similarly ABCY, it's become
Yes.
a parallelogram, and then this A would be like a midpoint of,
Yes.
and similarly B is the midpoint and C is the midpoint of this line segment. So if we drop so this is an isosceles triangle, and XYZ is an no isosceles. So if you drop perpendicular from X to A, then it will serve as a perpendicular bisector, and then since the
No, not perpendicular from X to A. What do you mean by that? Perpendicular from A to BC is perpendicular bisector of IZ, right?
Yeah. Then use parallel fact. They are parallel.
Yes. So
And since
perpendicular from A to YZ is perpendicular to
perpendicular
BC.
bisector and since circumcenter exists, ortho also exists.
Exactly. Very good. Circumcenter exists, the orthocenter also exists. Perfect. Is that clear to everyone? Fancier than angle chasing. We have not come across this term angle chasing yet. What are you talking about? Okay, good. So next is naturally. Okay, Pranav, take your pick. Which do you want to prove next? In center or centroid? Okay. Yeah, you all have learned fancy stuff now and don't know the basics. So I'll do the basics today. Okay, Shivam, go ahead. In center.
Yes. So we take the angle bisectors of two angles in a triangle, and they will intersect at a point.
Okay. Let's see. Yeah. Okay. What
So
now?
if you name that point I,
Okay.
and you drop a perpendicular from I to BC, I to AB, and I to AC,
Okay.
so you can prove by congruence that you name those points X, Y, and Z,
Okay.
and by congruence you can prove that IX is equal to IZ,
Okay.
and IZ is equal to IY. So
Yes.
IX will also be equal to IY. So the angle bisector of C will also lie on I will also lie on the angle bisector of C.
Perfect. Sorry, just give me a second. Try centroid for a second. I'll be back. Yeah. Did everyone get this? Why the incenter exists? You can speak. All right. Awesome. For centroid. This idea of looking at the structure this way is very good. Like setting up two things and finding some property that is equivalent only exists when this third condition happens. Yeah. Okay, centroid. What is the property that you will use here of a similar flavor? Who suggested Seva's theorem initially? There's somebody who said Seva's theorem, right? All right. Oh, lens bash. No, don't scare me. All right. How do you prove Seva's? And that should give you.
Using areas we prove the CVARs.
Good. So try to use a similar idea. We are not going to CVAs yet. We are not assuming anything about CVAs. All I'm saying is try to use a similar idea. Can we use area lemma? What is area lemma? Arindam, what is up with you? Ratio sides to areas thing. Yes, 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 perfect. Half BH is equal to area. That is okay. That you can use. Yes. So from this, your so-called area lemma that you just said immediately follows because you're only taking ratio of base. Yes, that is okay to use.
We name the midpoints D, E, F respectively.
Which are?
BC midpoint of BC, D,
Okay.
C, A, E, and ABF.
All right.
We join BE and CF and let their intersection be G.
DE and CF.
BE.
Okay, sorry. Ortho of medial in circumcenter. What?
Orthocentre, the DE triangle is the circumcenter for ABC.
Circumcenter for ABC. Also. I mean, sure, but like we're trying to prove that what you're saying is true, but we are trying to prove that.
Proof EF is parallel to BC.
Okay, how? That is a good idea.
That is his midpoint theorem.
How do you prove midpoint theorem?
Parallelogram.
Somebody was saying something. Go on.
I was saying that we can prove EF is equal to CF a parallelogram by proving the
Yeah. What parallelogram?
DFEC is a parallelogram.
How?
Because the E and F are midpoints of the line, so it will be parallel in half of BC, and D
Why?
is also midpoint.
No. How did that come to be true? I don't know that. How do you know that EF is parallel to BC?
We can use similarity. Triangle AF. Triangle A.
Okay, sure, go ahead.
We can extend DE, right?
Extend DE. DE to where? Where will you extend it?
Like on anyone, like on this side of BC, like from BC.
BA is twice of FA, and then
Sorry, can you repeat?
BA has twice of FA, and our angle FAE is equal to BAC, and then AC is twice of AE.
Sorry,
similarity is proved.
Please slow. Slow down. What you said is this angle, and then this is half, and then this is half. So something called similarity you are using.
So by so F
Okay.
is parallel to BC.
Okay. So firstly, I don't know what this similarity thing is. Sounds very nice. Secondly, yes, please go ahead, Shivam.
Yes. So what you do is you extend FE so such that it equals BC.
Okay. Let's say it went on till here.
Yeah, you name that point, let's say M. Okay, T. So you join TB,
Okay.
and then we know that AF is equal to FB.
AF
Angle
is FB. Yes.
Angle TFB equals angle AFE.
TFB equals angle AFE. Yes.
And
Okay, this is a very good try.
never mind. I did
No,
not
no, no.
get the third criteria.
Angle TBA equal to angle CAB.
TBA equal angle CAB. So you want these lines to be parallel when I create them.
Yes.
Okay.
So now we can use similarity, right?
How? What similarity again? Again, similarity, this magic thing that you're using again.
We are not allowed to use similarity.
We never have anything called similarity. We have congruence. We have isosceles triangles.
We have triangle AFE
So
congruent to
if you-
BFT.
Yes.
So
Good.
if you prove the congruency, angle FTB will equal to angle AEF.
Angle FTB will angle AEF. Okay. When you create this parallel line to that, you're already doing that. This is fine. As soon as you create parallel line, you'll get this
Right.
congruence. That is okay.
So this means that BC is parallel to TE.
Sorry, what? This means BC is parallel to TE. How?
Because if we take the transversal to be okay, sorry.
Like BT equal to EC we have, and BC equal to ET by construction. So like the opposite
No,
side.
no. Okay. No. Start from the beginning. How did you construct T?
EF equals FT.
Sorry. Tell me, how are we constructing T? First, we should agree on how T is being constructed.
T is a point on line EF such that TE equal to BC.
TE equals BC.
Like F is the midpoint of TE, then we can do easily.
F is the midpoint of TE. Sure. So let's. Okay, that is decided now that F is midpoint of TE. Sorry. Yeah. So this is T. And now how do we do? I don't know this parallel now. Okay. Now.
Then by SS, TB will be AE and AE is EC.
SAS. What are the two S things that you're using firstly?
TBF and AEFE.
Good. So by SAS, what is what?
TB is equal to AE and AE is equal to EC.
Yes. TB equal AE and yeah. Okay, now what? What does this imply? This
CE
implies
equals EA equals BT.
CA equals
CE equals EA equals BT.
yes.
So that
TB
implies
is
BTEC parallelogram.
Yes. Yes, it does. Very good. Okay, so you have finally proven parallel. Congratulations, and you have proven half. You have midpoint theorem.
So we have to prove the midpoint theorem here.
We proved midpoint theorem. They just proved it, right?
So I joined just now.
Yeah. No, we are trying to prove existence of centroid. So firstly, they were assuming that this is true. So I was curious how they're doing it.
Okay.
Okay, now what comes next?
Uniqueness of centroid.
No. Sorry.
Centroid.
We have not proved existence yet. How does uniqueness come into play?
Yeah.
We have proved that these line will be parallel. So like the medial triangle DEF has the orthocenter as same as the circumcenter of ABC.
Sure, that is true. See, the thing is proving centroid on ABC is the same as proving centroid on DEF. Somebody had an areas idea, right? Try to exploit it. Also, anyone who was talking about uniqueness, if you can show existence, that is enough. Because it is coming from the intersection of two lines. It has to be unique.
We let E prime be the midpoint of BG.
E prime be the midpoint of BG. What is E prime?
The midpoint of BG.
What is G?
G the meeting point of BE and CF.
Okay. So let's call this G and then consider midpoint of so E prime.
Similarly, we define F prime on CG.
F prime.
Then E prime F prime is also parallel to BC.
Okay.
Implying EF E prime F prime is a parallelogram.
Sorry, your voice got cut.
EF E prime F prime is a parallelogram.
E prime. Again, E prime, F prime, and what D and G are you using? Or like what are the other 2 points you're using?
EF
you're saying
E prime.
EF. Right. Sorry. Okay. How is this the case? Sure. Okay.
Can I tell using areas?
What?
Using areas. I think I'm done.
Yes. Okay. Go on using areas also, but like this is very good. I would like this person to complete their argument once.
Then we have GE equals GE prime.
GE equals GE prime. Sure.
And that equals BE prime.
Yes.
So this implies BG equals 2 times GE.
Yes. And you can finish now. This is very good. This is a very nice proof. I was not going for this proof initially, and I'm very happy that you came up with this.
Rohan, can I tell a proof using the midpoint theorem since we have proved it?
Yes, of course. You've proved it, so you can
Can we
use it.
draw a separate figure?
I would just I just want the other person to complete because they're very
Sure.
close.
Similarly, we will get CG equals GF. I mean,
No,
CG equals
no
2
need.
times GF.
No need. You don't need to do that. This is enough. See, you said BG equal to GE, and how did you define G?
To be the
BE
intersection
intersection
of...
CF.
Yes.
Now, if I define it using BE intersection AD, then I call it G prime. Then I again get BG prime is equal to 2GE. Yes? Sorry, 2G prime.
Yes.
So G and G prime are same. Perfect.
Yeah.
This is very good. We induct. Yes, for sure. Sounds amazing. Analytically, that works, but I'm not even going to comment how.
It actually how analytically? Like you always
Oh,
have some triangle, no?
yeah, it tends to something, right? And it's
To a
always
point.
it has to tend to a point. If it's like not tending to a point, it will that doesn't happen because the figure keeps getting smaller and smaller and smaller, and it gets arbitrarily small is the point, and it has to get arbitrarily small towards the point.
Yeah.
So that point wherever it tends to will be the centroid. That works. Not even talking about it. Yes, sorry, Tuheen, if I'm not wrong. Yes, no need to understand this proof. Ignore it completely. It's not relevant.
Okay, so we will draw triangle ABC and we take the midpoints F and E of side AB and AC.
And ABC. E. Okay.
And we join BE and CF and let the intersection point be G.
Okay.
So we will join AG and extend it such that extend it to a point X such that AG is equal to GX.
Okay.
So we have to here prove that and let it intersect at D with BC.
Okay.
So we have to prove that AD is the median, and so we will be done. And
Yes.
so we will join BX and CX.
Okay.
And by the midpoint theorem, we know that FG is parallel to BX and GE is parallel to XC.
Sorry, FG is parallel to BX.
BX.
Okay. X was such that AX is equal to
AG is equal to AX.
Yeah. Okay.
Sorry. AG is equal to GX. Yes.
Yeah.
Yes. So now we know that BGCX, it's a parallelogram, and
Yes.
the diagonals bisect each other. So D is the midpoint of BC.
Perfect.
Oh, how did you get BGCS parallelogram?
By midpoint
Because the
theorem, yeah,
pairs are,
go on.
yes, they're parallel. The pairs are parallel.
I mean, by midpoint theorem, FE parallel to BC, no?
FG parallel to BX,
Okay.
and FG is CG. Yeah, perfect. This works. And this also gives you the 2:1 ratio because 2, 2, and 1, 1. Okay, run of areas proof.
Yeah, so can you draw this figure ABCD here?
We really need to change colors after this. This is getting too much. Yes, DEF.
Join ADB is here.
AD, BE,
CA.
and CA.
CF. F.
Okay.
Oh. Define F as like the intercept, like let AD cap be EBG. So define F as that.
Okay. Sure. I did that.
Yeah. So now, wait a second. Yeah. GBD. Let the area of GBD be 1.
Area of GBD be 1. Okay.
So now GDC is also 1.
Okay.
Let area of EGC be X.
Area of
EGC.
EGC dx. Okay.
And so area of AGE is X.
Okay.
Now if we prove that X equal to 1, we will be done, right?
See, you don't need to worry about that. Why are you worrying about that? You don't need to worry about any of this. You're doing very well. Can you show that area of ABG is area of BGC?
Yeah. Assuming BE is the median, right?
Yes, yes.
Yeah, we can show that.
L proof?
So like ABE equal to BEC and
Yes.
GAE equal to GEC. So subtract.
Yes. Perfect. Yes. And similarly, by the way you did it, ABG is also AGC.
Oh yeah. Yes.
Again, magic equality condition implies these two are the same. That means F is also, like CG is also the median.
But I think it's not like fully complete. No? For that, we
Okay,
need.
let's say F dash. Now, the ratio of BGC and AGC, if I multiply both by CF prime upon CG, their areas become BF prime C and AF prime C, which are equal. Yeah, okay.
Yes.
Perfect. So the three proofs, are they clear to everyone? Others?
Yes.
Okay, awesome, awesome. So these were the four main triangle centers that you use every day. Okay, the first proof, I'll repeat it quickly. Right, so ABC triangle DEF, BE intersection CF is G. Now BG midpoint BE prime, GC midpoint BF prime. Now by midpoint theorem, FE is parallel to AG is parallel to EF, E prime F prime. And again, by midpoint theorem, E prime F prime is parallel to BC, which is parallel to EF. So we get that EF, E prime F prime is a parallelogram. Since diagonals intersect at G, G must be the midpoint. So we get that EG is equal to E prime G equal to BE prime. So we get that BE, the line CF, divides it into ratio 2:1. But if the line B is divided by CF, there's nothing wrong with AD. AD must also divide it into ratio 2:1. So the resulting point that you will have is the same point. There's another way to finish this. You have AG prime is parallel to FE prime, but you can also have that FE prime DG prime is a parallelogram. GD is also a parallelogram. Again by midpoint theorem, only you get this. So you get that DG is also parallel to E prime F. So we'll get that AG and DG are parallel, so we'll get that AD is a single line. Make sense? Awesome. Any other review on this page? All right. Now come Pranav's magical thing that he was talking about earlier in the day. Something called angle chase using circles. Who could have known? Okay. So this is something that you'll see. Double the angle at center. Fair enough. Since you love it so much, quickly prove it.
One second, I forgot it.
Again, don't try to remember, just prove it on the spot.
Okay, fine. ABC, draw the center. Draw point through the circumcenter. Okay, okay. Yeah, so join AO, BO, CO.
Oh no, we are back to brown. We already used this.
And green.
Help me with it. Red? No.
Orange.
Yellow.
Orange we already did.
Yellow.
Yellow is fine.
Yeah.
Let's go with yellow. Cool.
So since AO equal to BO,
Yeah.
angle OAB equal to angle OBA.
Okay.
Now, okay, extend AO a bit to a point.
I don't think this is very visible. Let me. Yeah.
Extend AO to a point D. Random point. Now angle BOD equal to twice of angle BAO.
Angle BOD is twice of angle
BAO.
You're saying this is double. Very some fancy result. Okay.
Yeah. No, I mean directly angles and properties, not
Yes.
the exterior angle.
Yes, very colorful figures today. Okay.
Now similarly, angle COD equal to twice of CAO or OAC.
Good.
Adding and finish.
So slight note that I'm just adding for no huge reason. The reason that I didn't write COD when you said COD is it can get confusing. In the sense, it's supposed to be DOC because we're kind of working in this type of orientation. We're starting from B and then rotating this way. And so starting from D, rotating the same way. If you write it the other way, it can get confusing. Even though you're assuming angles are always positive, then you can't be like BOD plus COD. And things are weird because then configuration issues can come up. Because this O could have very well been outside the triangle, right?
Yeah.
Like if it was something like this, then it might have caused an issue. Might not have, but like if you write it like this, it might cause an issue. So it's better to write it this way, with your preserving your orientations and all. Okay, very good. Did everyone follow this?
Yes.
All right.
Yes.
So this also gives this nice result. That if you have an arc, and if you have something here, and if you have something here, then this angle is this angle. Can anyone quickly tell me the proof?
We consider the center.
Okay.
Now using 1, we have angle AOB equal to twice of angle ACB.
Good.
And angle AOB is also equal to twice of angle ADB.
Yes. Perfect. Can you prove the if and if only if condition of this? That if D was not on the circle, then this would not have been the case.
We like take, let's say D is outside the circle at a point D dash, and we then do stuff.
Let's say D dash.
So define a like, can you raise the previous T? So now join AD.
Sorry.
Join
Yeah.
AD dash. The outer point is D dash. Yeah, it intersects at D. AD dash intersects circle at D.
Okay.
Now join BD.
Okay.
Using the previous thing, we have angle ACB equal to angle ADB.
Yes.
But you are saying angle ACB is also equal to angle A dash AD dash B, which is
Yes.
not possible because like then this D dash BD part gets added. It should be 0.
Yes. Perfect. And last, here is the consequence of this. If this was on the opposite side of the circle, then their sum is 180.
We can also approve the previous one without using one. No?
Yes. This. Yeah. You should be able to do that.
Yeah.
But one appears will appear in some form just because it's in the crux of it. It is a very direct argument.
Yeah. Okay.
Okay. So these sum to 180 if and only if ABCD is cyclic. Proof, anybody?
Okay, so consider the center O again.
And
Wait, what do we have to prove? Like if their sum is 180, they are cyclic, right?
either way do it. No, it will be the same thing because you proved it earlier in this result.
Yeah. So like join BO and DO.
So you have O, VO, and DO.
So I'm proving that angle A plus angle C should be 180. Join AO and C.
Okay.
Now angle AOC should be twice of ABC. And the reflex of AOC, like the upper part, that should be angle. Oh, yeah. It should be twice of ADC. And we add them and then 180. Like that.
Yes. Which is exactly what we wanted, right? Awesome. Right. So till now, all of this is clear. Perfect. Perfect. All right. Let's try some stuff with parallelograms. You guys are already very good at this. I was very impressed with your centroid stuff. How does one spell this? I hope this is right. Otherwise, it will. Reverse direction, of course. So in case I'll just write it out because I want to spend we only have half an hour more or so. So because this angle plus this angle is 180 and this angle plus this angle is 180, you get that these two angles are equal, which implies this angle is 0. Yeah? Is that okay? Cool. Parallelogram. All right. So I have a triangle with area 4. Area 4. And now if I consider this line, let's call it MA, like the median. And similarly, I consider MB, and I consider MC. And I construct the triangle with these as the sides. Yeah. Now, can you prove that, like, okay, can you find the area of the triangle with these three as the sides?
These are the lengths of medians, or
Yes, yes, yes. Like I can like move them somehow and arrange into a triangle. Like MA is the like you have some line which is the median, right? Let's say AD. So if AD has length MA and BE has length MB and CF has length MC, you create a triangle out of this. Like take these three lengths and somehow arrange them to form a triangle. There will only be one such triangle because of your SSS criterion. Oh no, 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 no. Why do you upset me, Pranav? Why do you upset me so much? You guys have done this already. Let me add this. Today you have proved this already.
is it like we construct parallel lines to the sides from the vertex?
Yeah.
No, 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 no. Gunjan, you have already done it. ABC triangle, D midpoint of BC, E midpoint of AC, and F midpoint of AB. Length of AD is equal to MA. Similarly, you define MB and MC. What is area of triangle sides MA, MB, MC?
Do you reflect G across D?
Okay.
Then G, that point will be 2/3 of MA. And B, that point is 2/3 of MC.
Good. Bx is equal to AC is equal to 2 by 3. Sorry, MC.
Bx equal to GC.
Yeah, why is writing so hard? Similarly, this is 2/3 MA, 2/3 MC, 2/3 MB. Yes. Answer is 3. Yes. Go on, Atul. Atul. Have you just disappeared? Amazing. Okay, somebody else wants to take over for him. Gunjan, it is your proof. You can complete.
So basically, BCX is just similar to a triangle with sides MA, MB, and MC. So we just take midpoint of not BCX, BGX, midpoint of BG.
Okay, midpoint of BG. Why do you need midpoint of BG?
Oh, sorry. I thought we have to construct the triangle. Okay, so this is just 4 by 9 of the area we need to find, and this area is just 1/3 of ABC. So 9 by 4 of 1/3 of ABC.
Yes. 9 desired area. Okay. And this is what? This is 1/3 of ABC. How?
Because BDX is DXC, which is GDC, which is
BGX is, sorry, BGC you said, right?
BDX
BDX
is DXC,
yes,
which is CDG.
right. So this is, you're saying BGC, yeah. Go on.
Which is just BGA and GCA, so it's 1/3 of ABC.
Yes. So we get that 4/3 is equal to 4/9 desired area. Less desired area is 3. Also, those of you who want to and are going to contend the use of similarity, there is no need to, because what she has used similarity here is just that you have 2/3 the side lengths. Then how you use it? You can do that directly by just taking 3 halves this side length, then 3 halving this, and then 3 halving the required side length. And that is consistent. Okay. So you don't need to worry about that. Because of this repeated 3 halving, you've multiplied by 9/4. And then you have congruence already. And why, you may ask, why 3 halving resolves things? Just because of your midpoint theorem. You can do it on half part and then replicate. Right. Okay. Right. Can't we do by Heron's by taking ratio then? How will you use Heron's? Like, firstly, you'll need to find what MA is, which is already very messy. And again, you have no idea what this Heron's thing is. You haven't proved it. Yes. Also, like, whosoever had commented that the area must be 3, you're absolutely right. And we've just found that. But what I wanted was this proof. This is one of the proofs. The proof I had in mind is slightly different. I'll just say it. ABC triangle. And let's say this is E. So remember, we just constructed T. Yeah. And instead of T, okay, T is fine actually. What am I doing? Wait. This, yeah. T. Yeah. Heron's proof always brought a tear to your eyes. I cannot do anything but agree. No, 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 no. I'm never going to prove Heron's for. No, no, not happening. Why would you do such a vicious thing? And kids these days just want to mess with you, not let you have a good life.
You also committed sins. We are not the only ones.
Right. Finally, yes, we constructed T and we had D. So remember how TD FC was a parallelogram? And BE, AT was a parallelogram. So AT is equal to BE, CF is equal to DT. So their desired area is ADT. Yes? Is this okay? Okay. Desired area is equal to ADT. Now ADT area is area of ABT plus area of ACT divided by 2. Is that okay? Right, okay. So this you can do just by dropping perpendiculars here. Extend it and then drop perpendicular and do it. Yeah, okay. So now, okay, what is area of ABT? Area of ABT is just area ABE. And ACT is just ABT. Sorry, ABC. Upon 2 is equal to 3 by 2 ABC upon 2 is equal to 3. Okay. Does this make sense? All right. All right. Finally, we'll end with this thing called the Simpson line. Can you just define T again? T is the point such that BTEC is a parallelogram. And we proved all these results that I used in the problem where we were proving existence of, we were proving midpoint theorem, and we proved all these results already. Okay, Simpson line. This is the last thing. How no questions today? What do you think? Like, these were questions. Like, okay, so when I ask you how to prove circumcenter exists, or like how to prove orthocenter exists, those are things which are called questions. Is that okay, Pranav? How, why, all of these are questions, yeah. Okay, so we have this really cool thing for all of those who are not aware of it. So if you have a circle and you have a triangle, ABC, let's say. And you have any fourth point on the circle, let's say P. Now if I draw perpendicular onto these three sides and call them X, Y, Z. Firstly, X, Y, and Z are supposed to be collinear. And secondly, if you consider the orthocenter here, H of ABC, then this line bisects PH. Please prove how. Both of these things. Okay, also those of you who may feel this is a bit too much, alternately try this problem. Firstly, prove that in a right angle triangle, the median is half the side length. We have the hypotenuse. I'll tell you this, like when I just started Olympiads in 10th, like I had no experience. Like I was studying for pre-RM or something. I was like amazed by this result. Whoa, you have the median which is like half the length, and I was like, wow, this is crazy. And somehow I knew the median length formula and I took it out by that, and I was like, oh, this is why it works. And then I later looked back at it and I was like, oh my god, that kid. Yes, don't worry about median length. It's not good. Yeah, I started in 10th. Yeah.
I just realized that PH is bisected. Can be done by complex also. The coordinates will be no. Just another method.
I'll remove you from meeting next time for saying such a thing.
I mean, it is good. It is
No.
used in competitions.
Don't.
If you get a medal using complex, and then you don't, that is the former is better. No.
I won't care about your medal. But I will stop respecting you.
Oh, you do? I won't say from next time. Sorry.
Okay, fair enough.
Can you tell the collinear part?
No. You said, can you tell the collinear part?
Yeah.
Go ahead.
I don't remember, so I'll just do it side by side.
Sure. The confidence is amazing. I like it.
Byz equal to xy c we have to prove. So let angle byz be alpha.
Angle by alpha.
Now angle bpz is alpha.
Why?
Oh, because like angle byp and bzp is 90-90, so it is cyclic.
Good. First claim is by is the PC cyclic. Yeah. Perpendicular 90-90. You can figure it out.
Now
Yeah.
zbp is 90 minus alpha.
BPZ is
zbp
is angle ZBP is equal to 90 minus alpha. Okay.
So now angle ACP is also 90 minus alpha.
Angle ACP 90 minus alpha.
Which is equal to angle XCP.
Into angle ACP firstly. Okay. XCP is equal to 90 minus alpha.
Now, which means angle XPC is 90 minus this, which is alpha.
Sure.
And now, since PYX is also cyclic by that 90-90 thing, so XYC is also alpha.
Good. For collinearity, you got it. Is this proof for collinearity understandable for everyone? All right. Okay. No. Let firstly prove that Simpson line, this line, which we just made, bisects PH.
For that, do we first not prove like if, let's say, py cap ABC is some point t, then it is parallel to Simpson line.
Again, what is this business of do we not do this first? What do you mean by that? I don't understand this.
I mean the way it was defined in EGM.
Again, forget it.
Fine.
Just do it. Just carry out the proof. You don't need to know stuff in advance. I have a question. Why non-synthetic? I don't understand why you like them at all. Like, there's nothing else. You are doing calculation. Why? You gain basically no intuition about the structure. After reading them, you don't feel happy. I've never felt happy after seeing a complex bash once. The only reason I felt happy after finishing a complex bash is just because it's finished. It is not because, oh my god, this is so nice. When I do synthetic proof, I'm like, oh my god, this is so nice. What is complex bash? A technique evil people use to do evil things on nice problems. And that nobody should know. RG loves MMP. MMP is supposed to be good, but the thing people have turned MMP into is, again, not remotely relevant. Don't worry about it. Don't think about it. MMP used correctly is synthetic. The way people use it is not. Again, don't worry about it. I'm not going to teach MMP, not at all. No. Again, don't worry about it. Method of moving points. Very fancy things for unnecessary reasons. The maker of MMP did not know it's called MMP. Don't worry about it. Oh, Anand came up with MMP. Yeah. Again, you guys are not focusing on proving Simpson line bisects PH. What are these fancy techniques you're using? I keep forgetting.
Does pH bisect exit?
What bisects what?
A pH bisect XZ.
If pH bisects xz, it must also bisect yz and it must also bisect yx because of symmetry. Like there's nothing special about x and z right now. P and H are independent of like the order A, B, and C are built in. X, Y, Z are not. No, the point is like X, Y, Z are not independent of the order A, B, C are baked in. If you rotate, like if you changed figure from ABC to BAC, P and H are the same thing. X and Y get exchanged. So that would mean x, it's also the midpoint of y and y. Because the same proof should. Okay, this is now your homework problem because we are running out of time. I'm calling it a homework because of a lack of better term. I would recommend you try it. It's very nice. It's very clever use of parallelograms. Don't worry if you can't do it. It's a tricky problem. Yufi Zhao has a very nice handout in the first part of which he basically lays out the proof. I think there's a particular thing on Simpson Line which you might want to look at. It's very nice. Who has handout? Yufi Zhao. I think his version is very nice. Okay, did anybody try the right angle triangle problem?
Oh, what was it?
We can take the circumcircle of ABC and BC will be a diameter.
Sure. Let's go with something simpler in some sense. Again, because that would mean wide diameter and all that stuff I don't want to bother with right now. Reflect A on O. Okay. You have a parallelogram. Similarity. No, not similarity.
Oh.
Just a second. Okay, what do you do with this parallelogram? Okay, I'm not able to find a UF's thing. So you have to look for it. Pretty sure he had something. AD equal to RHS. Sure. Yeah, RHS should work. Again, okay, what I was actually going for is a little more direct. This angle you proved is, let's say, is alpha, and this angle is 90. So, sorry, what? Okay, sorry. I'll take. Yeah. Let me take the what is it called? Perpendicular bisector of AB and let it intersect at D. Yeah. Now this angle and this angle are the same angles. Yes. And this angle and this angle are the same angle. So you get that AD equal BD equal DC. Like BD equal AD equal DC. So AD is half of BC. And it is also BD and it is also DC. Yeah. Awesome. This is what I was trying to get. And of course, if you reflect, this is a rectangle and these two diagonals become equal by RHS slits. All right then. Yeah, but somehow I like the first part of the proof better for some reason. Yeah, and any doubts, anything? I have no idea, no time right now.
I had a doubt other than this. I
Sure.
mean, like geocellular.
Go on.
So, like after learning many techniques, so do you like prepare some list and whenever you are trying a geo question, just go one by one over the techniques to try which one?
Never, nothing, no. What? No. If you're worried and don't know what technique to use angle chase. Forget everything else.
I mean, sometimes it's very convoluted and angle chase directly doesn't work. I tried that.
Doesn't matter. To develop geo skills, it's okay. Doesn't go well, it's okay. You have enough time. Practice and get better at it. Angle chase is the only thing that's going to get you through at the end of the day. You might want to improve on other areas which are, say, fancy things, but if you're not good at angle chase, you'll always struggle with geometry. Unless you're using evil techniques, then you're just struggling with geometry. Because then you don't know what geometry is. Like, see, it's very nice that you know Saver's theorem and you can prove Saver's theorem. Very nice. But if you can't tell proof of circumcenter existing using perpendicular bisectors and equality, and if you say the proof using that, then you're doing something a little wrong. It's very nice. The author sent. Okay, I'll check mail. Which ID is this? I might have missed it. Sorry. RG.me. Okay, I'll check it once.
No, I'm asking. I didn't send you the mail. I'm just asking if you still use that mail.
I mean, it exists and I do get notifications, but I miss it sometimes is all. Yeah, you can end recording.